go ahead and start this. So today we're going to go over your practice exam for your exam. This is a lot like what you'll see. It's going to be out of 100. So there's going to be out of 100 points, but there's 105 points. There's 4 explicit extra credit points on the exam, one of which is a survey. It will look big and hefty. Do not, freak out about your actual exam looking like it's 16 pages long. That's just simply because I have a couple of the pages don't even have questions on them, and another couple of pages are extra credit, and for a lot of the other ones, I give you the entire page to code because I want to make sure you have plenty of space, even though some of the questions will be very short to answer. Okay, so please, keep this stuff in mind. You're allowed to ask. You're allowed to clarify your answers. You're allowed to ask for clarification, meaning that you can basically write down what your assumptions are, and we take that into account when scoring your problem. If you need to work on that if you need to make assumptions, you are allowed to ask for clarification. You're allowed to ask us, what the heck does this mean? And we might even be able to tell you. So on the actual exam, which I will, let's see, do I have, on the actual exam, did I go through it? I'm going to, hopefully I won't have to do any video editing when it comes to this. Okay, yep, on the actual exam, which as you can see, there's a bunch of pages. It looks like there's a lot of pages, but you'll notice there's some gaps in the pages because there's no stuff there. I have actually listed for you the important string methods and the list methods as a reference for you. You do get to bring in a cheat sheet, but that's just there for you. Okay. Extra credit is available for exceptional answers. So really good answers and really original stuff and really funny stuff that gets us, that'll get you extra credit. Don't panic, which is possibly my best piece of advice. You have the entire 2 hours to do this. So, I couldn't make the font friendly though. So, all right. So this is pretty much exactly what you're going to have on the first page of the exam. The only difference is basically the actual specific question. So here we're just trying to figure out which A, B, C, or D it is. So D, dot previous, dot previous, dot next, dot previous. So D, dot previous, dot previous, dot next, dot previous. Right? We start at D, we go back, back, forward, back. So it's B. Okay. C, dot next, dot previous, dot previous. So C, dot next, dot previous, dot previous. That's also B. And then we've got this long one over here. And then we realize though that since I have so unless we're starting at B, but unless I go 3 over, right, and go out of bounds, it should be fine. That all I can do is just count these next and previouses up and cancel them out and then simplify it. So 2 nexts followed by 2 previouss, those cancel out, and a next and a prev and a next and a prev, those cancel out. So this is a bunch of nothing. I end up at B. So the answers are all B, and yes, I sometimes do that. I don't think I've done that for your actual exam, but I have. But on the 1068 exam, who's having their first exam on Friday, I have a bunch of Boolean expressions that they do need to evaluate, and they all evaluate to false. 5 of them, and they all evaluate to false. And there is a 1 in 32 chance that is actually, if I randomly generated it, that's what it would be. So I'm going to skip these questions because this one's a really easy question. This one's a less easy question, but it's similar to one you've had to do in your lab. So I'm going to skip those. And I'm going to skip to the linked list problems because those are the more important ones. This one's easy. This one is probably the hardest one I have. This one's actually looks hard, actually really easy. Okay. This one it's actually it's an easier version of an interview question. So I'll tell you what the interview question is, it's actually pretty obvious what the interview question is from that one. And then this one's the stack problem, and then the analysis problem. So we'll go over those first. So let's first start out by writing a sequence of commands that will remove the tail of a linked list. And here I have the directions of what you need to do. So you've got, linked list is a bunch of nodes. You've got a head. You've got a tail. Just reminding you that there's a size method, and that I mentioned that the nodes are doubly linked and they have next and previous. Okay. And I think on the exam for some problems I allow you to choose whether you want to use a doubly linked or a singly linked, right? So if I see a prev, I assume you're using a doubly linked. But if I see a next, I assume it's singly linked. So if I just see next but no previous, I assume it's singly linked. So that is pretty simple like that. Okay, so write a sequence of commands that will remove the tail of a doubly linked list. So I find that the best thing to do for these is to draw them. So I'm going to go ahead and go up here. So I always also like drawing 4 nodes, and actually on the exam it's actually the reverse, where I'll give you commands and I'm going to ask you to draw it. So that's one question I'll give you. I'll give you a bunch of commands and I'm going to ask you to draw. I'm going to ask you to start with this and draw what happens to the linked list after a bunch of commands. Okay, and you're allowed to give me, well, it starts like this, then it goes to this, then it goes to this. So right, for a doubly linked list. Right, though, this is head, this is tail, so this is a doubly linked list, so I need arrows like this, right? I need a previous. And then I need a sequence of commands that is going to remove the tail. So I know that the first thing I have to do is that if I'm removing the tail, this thing has to be the tail, right? Tail is equal to tail dot next. So not dot next, dot previous, right? So this becomes the tail. But that doesn't get rid of this because the tail is still pointing to the next thing over there. So in order to remove it, I have to go tail dot next is equal to null. Okay? So just a reminder of how that works out there. So, so that one is actually pretty short and pretty easy. There's not too much to that problem. Okay. The key is that if I give you a problem like this, right, and so on the exam, the reverse is it's kind of the reverse, where I tell you, start with a note, a linked list of 4, right, and draw what happens after I give you some commands like, like I'd use a current, and then I'll move it around a bit, and then I'm going to move the pointers a bit, and I'm just going to ask you what happens to those, right? So it's nothing too complicated because the linked lists are only going to be 4 big, right? 4 is kind of the perfect length for messing around with them. They're not too big and they're not too small. Okay. Let's go ahead and go to the actual toughest problem on the exam, which is merging 2 sorted linked lists. So I actually like the idea of sorted linked lists. I've discovered that that dealing with sorted linked lists are beautiful problems for an exam because they're just different enough that basically you can't really that they're tough, so that they're new, but they're not too new. So I really like these things. So this is a method. So and I remembered it because I remembered about merge sort, which we're going to learn in chapter 8 or 7 or something like that, which is basically let's write a method that takes in 2 sorted linked lists and merges them into a single sorted linked list. So now this question is, I'll try to be better with the phrasing later on because this is the first time I've given this as a practice exam question, which is, so now you have to ask me questions. Is it okay if I remove stuff from list A and list B? And the answer to that for my question would have been yes, it's okay for you to remove stuff from list A and list B. Okay. If it wasn't, of course, you could just simply create copies of list A and list B and remove stuff that way. Okay. So it's a static method. You can't access the nodes, but you could use an iterator if you want to. I mentioned this in the actual exam that you can use an iterator if you want to, but none of the questions will require an iterator. Okay. So let's then start and let's just figure out how before we jump into coding, let's just understand what's going on here, right? That is kind of the question. Okay, we want to merge stuff. So that means that if I am given so if I take this problem, I have 1, 4, and 10 as one linked list. And then I have 2, 3, and 40, 45 as my second linked list, right? So they can be different sizes, right? Then the result is that I want my output to be a linked list that has 1, 2, 3, 4, 10, 40, 45. Right? I'm taking two linked lists and I'm sorting them together. So first things first, let's come up with a dumb solution, okay? Right? It's an exam, not pressed for time. Let's just get something on the paper that works, even if it's not efficient, okay? Because eventually I might start grading you on, because I'll start grading you on efficiency soon, okay? Let's get something on the exam on the paper that works. So let's add them all to a, let's take all, so let's go ahead and create a new linked list, like linked list out is equal to new yada yada yada. I'll fill that in later, right? New linked list, and I'll do out dot add all, an actual command, list A out dot add all list B. Okay, and then what is it? Collections dot sort list. So out. Right? Can I even sort a linked list? Hope to God I can. Okay. Right? And then I guess I'm done. But it makes it almost impossible for you to correctly answer the second part of this question, which is, what's the time complexity of this algorithm? So you're taking a 2-point hit on this. So, because first off, you don't know what collections.sort uses. I don't even remember. Is it quicksort or is it timsort? Wait, what the heck is quicksort and timsort? Okay, I'm not sure, because I know it used to be quicksort, but then timsort came along, and everybody started programming that in. Or is it even using merge sort? Oh, and furthermore, not only that, depending on how the algorithm works, right? Getting the ith item of a linked list, remember, you have to iterate to that. So does that the effective time? Does the runtime of the algorithm suddenly go from n log n to n squared log n squared? Right? So you have to actually analyze it. Linked lists are tricky, like that. But that is a solution, and it will work to an extent. Right? Yeah?
So how does add all sort everything?
Add all does not sort anything. It just simply slaps everything in and slaps everything else in, and then you tell Java to sort it. Okay.
I'm just wondering why we were calling it a solution.
Well, because collections.sort will sort it.
Okay, I didn't see that. It's like blocked by the computer.
Better?
A little better.
If you add all that way and then actually write a collections, like a sorting method, instead of like using the collections.sort, the add all isn't going to really affect the time complexity, is it? Or
no. Add all won't. So add all, that's going to take, I have to iterate through all the items and add them in here. I have to iterate through all the items and add them in here. It's going to take you O(n) time in total, right? But let's then say, though, let's say I actually had but because I realize this is a solution now, next time around, I'm going to add a disclaimer on this. You cannot use collections.sort. Okay? So now we actually have to think about this. I mean, you could write your own sorting method, and that's fine. So, but let's think about this. How can I actually, physically sort these two things without, writing the sorting algorithm? Because this is actually a problem that linked lists are really good at. Because these two things are sorted. This isn't your standard sorting problem. Yeah?
You could start with an iterator on the first list.
So we can start, yeah. Well, we could start with an iterator on the first list. But basically, what's the key here? What should the algorithm look like? Let's stop thinking about like iterators and yeah.
So you start at the heads of both of them, compare the data in to them, and then go next to the next value.
Yep.
Depending on whether or not it's greater than.
That's exactly correct. So this is where I say basically yes, you can actually remove the stuff, or you could use an iterator, but removing the stuff is easier. So the key there is that we can just look at the items in front because they're already sorted. So let's compare 1 to 2. Which is smaller, 1 or 2? 1 is smaller, so that's going to go in first. We'll just cross that off. We'll remove it. Okay, which of these is smaller now? Which index 0 is smaller now? 4 or 2? 2 is. Remove that one, put it on here. 3 or 4? 3 is smaller, so we'll cross that off. 4 is smaller than 40. 10 is smaller than 40. And then we've got 45 and 50 left over, and we can just simply add all of those over to the end of the list now, because we're empty. Because that's empty, these things are sorted, we don't have to compare them against each other. Yes? It does have an empty method, or you can just always check if the size is equal to 0. So, let's put this into an algorithm. Okay? So, while list A dot size is greater than 0, and if you can't write ands or anything or do a weird symbol, then you can just use capital and. Yes.
So this A and B are sorted.
Yes, they're given to you sorted.
Oh.
They're given to you sorted, right? So it says it takes in 2 sorted linked lists. They're already sorted for you. And now we have to merge 2 sorted linked lists. And list B dot size greater than 0. Sorry if I went under. Yeah, that looks terrible, but whatever. Okay. So if list A is greater than 0 and list B is greater than 0, that's what I get for trying to write. Okay. So long as they both have stuff in them. Okay, what are we going to do? We are going to, and we need a variable, so we'll just have a linked list out is equal to new, blah, 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 blah. Okay, so, while list A, that's what I get for trying to write too fast. List A dot size is greater than 0, list B dot size is greater than 0. We'll do this. If list A dot get 0, so get the head of the linked list, right? Yes?
Are they the same size?
Not necessarily.
So don't we have to modify the law condition there?
So long as the sizes are greater than 0. They're both.
What if you run out of 1 and then doesn't have to continue?
I'll get to that. Yes, one's going to always run out of the other. One is always going to run out of items in it before the other, right? So while list A, so first we're going to look at the heads of each of the lists. List A dot get 0. If the item from list A is less than the item at the front of list B, and we can just use less than directly because it's a guaranteed to be listed integers. So then out dot add. Well then, so sorry. First, we look at the 2 numbers, right? If the list A number is smaller, we'll go ahead and remove it. So int x is equal to list A dot remove 0 list A dot sorry, then out dot add x. And honestly, we could just simply just make this one line where we just do the removal in one go. But I wanted to do, I'll do that on the next line. Okay. So we just remove it from the head of list A and add it to the tail of list of the output list. Okay. Else, well, that means that the item in list B was bigger. So I'll do it in one line this time. Out dot add list B dot remove, right? Because remove, if you remember, returns the item that you're removing. So it allows you, and the reason we return is because it makes it easier to do very short code like that. So we're going to add the head of the item, the head of the list to the tail of our output list. And we just keep doing that until we run out of space. So until we run out of items in one of the lists. Okay. So now, though, inevitably, one is going to have, even if they start out evenly, with an even number like 3 and 3, you might remove 3 from one and 2 from another, or 1 from one and all 3 from another. So there's going to be items left over. So you got to add those remaining items to the back of the list. So we just simply ask if. Actually, we don't even need to ask. We can just simply tell it to add everything. So out dot add all of list A. Out dot add all list B. Don't even have to write a conditional here because it's going to list if list A is empty, this is going to add nothing. If list B is empty, it's going to add nothing. But for list A, but if list A still has items in it, it's going to add everything from list A. List B has stuff, it's going to last. And only one of these will ever have something in it. So we could write a conditional to do this, but why bother? We're pressed for time. It's an exam. Let's make it as short as possible. Return out. So now the second part of this question is, what's the big O of what is the time complexity of what you just wrote? Well, so we're going through all. Yes.
Should the condition on the while loop be an or? Because
no, so long as so long as both the items have something. So long as A has items and B has items.
Oh,
okay. So first, so we're going through all the items here, right? If we don't get all the items here, we're going to get them in the list A. We're going to go through each item once. We're going to go through a bunch of items here, and we're going to go through the remainders in these two statements. So we're going through each item. So we're going to check each item at least once. So how long does it take to get to each item? Well, here we're just I assume we're just going to be iterating through. So these will take. So this will take however many items there are left. But here, let's see, list.get .get 0 and get 0. That means that this is a checking. So getting the index 0 in either an array list or a linked list, that's going to be constant time, right? Because you're getting the head. Here, the remove. Well, in an array list, that would be terrible. That'd be an O of n operation. But these are linked lists. I said so. I forgot to write over here. I forgot to write over here that they should be linked lists as well. But I told you that they would be linked lists. Okay, so for this analysis, removing the head, that's a constant time operation, right? And then adding it to the tail, constant time operation. So this is so to add any particular item, so to check the heads and then add one of the heads, that's a constant time operation, right? So we only do so we don't have a linear time operation for each item. We have a constant time operation for each item. So this means that basically this is an O of n algorithm for combining these and producing a single linked list that's sorted, which is about as good as it gets for these kind of problems. So it's O of n. If you wrote so don't worry, I'm not grading you on efficiency for this one. There is a 5-pointer question on the actual exam, which does where I do give you the instruction to make your solution as efficient as possible. But it's 5 points, and it's really not so bad if you think about it. If you just stop and think. So here's the other one. This one is again not nearly so bad. Right? It looks terrifying. So the interview question typically you get is write a method that reverses a linked list. Then they just give you that prompt. Okay, and that's the way a lot of good interview questions work. They just give you a very open-ended prompt, and then they'll tell you to refine it, and you can write a method. So we come up with like our idiot solution there, where we just do something. So let's come up with a very basic solution that will solve this problem. Okay, and right here I'm using doubly linked so that basically that it's easy. This method will be an instance method for linked lists, so you can use the node's head and tail references and refer to the linked list object using this keyword. Objeki. So this is what I get for writing practice exams at after putting the kid to bed. So so okay. Did anybody come up with some solution they want to share? Yeah.
Just make a new list and start copying over the elements.
And start copying. Yeah, make a new list. Start at the tail of the original linked list and just work your way backwards, adding all the items to the new linked list. At that point, once you're done, what do you need to do? You need to set your old head to the new head, your old head to the new tail, your old tail to the new head. Right? You got to swap the heads and tails around to make sure. And then you've also got to make sure that that basically everything gets copied over appropriately. So let's go ahead and write that solution down. The solution I liked was for every item in here, remove it from the linked list. Okay. For each item starting at the head, remove it from the linked list, add it to a stack, and then then pop each item from the stack and add it to the tail of the linked list. That's to your empty linked list, and this will just simply repopulate your linked list, and it's going to take care of everything for you. So, these are some really good solutions for those. But let's go ahead and go with that with the solution that was also given in the evening class, which is just make a new linked list and copy everything over. So for E item in this, right? This is a linked list. Yeah, so for everything so what made this one weird is basically, since it's an instance method, you have to refer to it as this, right? So for every item in this linked list, we need a new linked list, which I'll just simply put LL list, right? And this will be our new linked list, okay? And we can initialize it and stuff, but again, my hands, they don't stretch that far. I need like a stool or something. So for every item in this list, list.add. Well, adding each item, so here's the key. If I did this, it would just simply put it in the same order, right? So what I need to do is I need to add each item to the as I'm going through it to the head, right? So what I instead need to do is do add to index 0 this item. Okay. And then we can basically then copy every item back over if we really need. There's a lot of ways to do this. Honestly, copying every item back over is the easiest way to do it. For each item in the list. Oh, sorry, and then there's another key. Well, there's the issue there basically that now that we've copied every item over to the old list, we need to remove all the items from the linked list, which means that we have to write a for loop to do that. There's also another method to do that, which I'll just use here. This dot clear, I believe, clears out the linked list. It empties it out. Look it up on the API just to make sure I'm not BSing. Oh, and I forgot to switch over. So, okay. And then for e item in list, this dot add. This is actually a lot more simpler than what I did last night. How much time does this take? Well, this takes O of n time. Clearing takes O of n time. This takes O of n time. So they're not nested, so they're just all O of n. It's 3n, right? Only multiplies when basically you have something inside something else. Basically, each item does n operations, right? So this is one solution. So there's a lot of good solutions, like there's the stack solution. There's actually another one is actually physically manipulating the pointers, like going through and manipulating the pointers, which is actually what they build up to in the interview question, because the next thing they ask is, okay, that's great. Now do it with a singly linked list, right? You're using a doubly linked list. Let's move it to a singly linked list. Okay, and now let's do it where you don't use any extra data structures. You don't create any lists, extra spare lists to do this. You're allowed to create some extra nodes, but
Can you re-explain how that reverses the thing? Like, I think I was a little lost following the code.
sure, no problem. Let me I'll just do it with like it's a singly linked list right now. Okay? So for each item in this list, I add, what I'm going to do is that for each item in the list, I'm going to add it to index 0 of the new linked list I've just created. Okay? So for each item in this linked list, I'm going to add it to list. So 3, I'm going to add that to index 0. Then 2, I'm going to add that to index 0. Then 1, I'm going to add that to index 0. Then 0, I'm going to add to index 0. This dot clear removes everything. And then for each item, I add it to the tail. Make sense?
Yeah, I get it now.
And then this will go, and then list goes away at the end of this. At the end of this method. So it's actually a fairly straightforward thing to do. The other solution is just to throw everything into the stack. There's a lot of good solutions to this, but the solution that typically the 45-minute interview session goes up to is let's create a method that flips a linked list, and the way we do this is by torturing you so that you don't get to use any additional copies of the linked list. You have to actually physically manipulate the pointers. And that's a tricky question to solve. But honestly, go for something that works a lot of the time. Okay, so let's go and back. So this one didn't have a big what's your big O, but that was probably almost all the questions that I have you work with do. All right, so now this one's not a linked list question. I forgot to put in the section header to say this was a stack question. This one is write a method called balance per n, which given a string representing an expression, checks to make sure the parentheses and only the parentheses of the expression are balanced. Right? So here, this is a simpler version of the problem I solved in class, which was checking to make sure basically the expressions were balanced with parentheses and brackets and curly braces, right? Here I'm just trying to make sure are the parentheses balanced. And I didn't go into too much detail more detail about this because it's something we've done in class, right? So I figured that basically it would hopefully you'd hopefully remember this from the problem we did in class. So it returns true if it has a balanced parentheses. So All right, to solve, when I get a Boolean question like this, like show that this is something, basically I have to choose one state as my default. So I'm going to assume that this thing returns that. Basically, if I get to the end, I'm going to return true. If I can get to the end, I am going to assume that this thing is a balanced expression. Okay. So, and I take in the string expression. So let's go, I have to go through each character in there. So for int I is equal to 0. All right, and remember, as a reminder, what I'm doing is I'm checking to make sure like you've got expressions. I'm making sure that you've got like 3 plus 4 times, 5, times f of x. We're trying to make sure, we're checking to make sure that we have the proper number of parentheses, okay? And that the other thing is to make sure that basically that the parentheses occur in the right order because, right? So here we've got the correct number of parentheses, open. Here we have the same number of opens and closes, right? But they're in the wrong order, they're not balanced. So that's why we use the stack for this, because every time we see an open, it needs a close. But if you see it close before you have an open to close it with, then that's a problem. So then it was exp.length, right? Remember, it's .length for strings with parentheses, .length for arrays without parentheses, and then it's .size with parentheses for your lists. Because Java hates you. Or at least the developers seem to. I mean, I know Oracle does. Not really, but we can't, honestly, it's really hard not to take Java at Oracle. Okay, so I dot expression, okay, so here we need to go through each character. C is equal to expression get car. Sorry, no, it's not get car, it's car at, right? And in case you forgot, that's listed at the beginning of your exam. Or will be listed at the beginning of your actual exam. Okay? So get the character C. Okay. Now basically we just check two things. We only care if it's a open parentheses or a closed parentheses. So if C equals open parentheses, sorry, C is equal to open parentheses, which looks like a capital C, to be honest. To do one thing, and then else if C is equal to a closed parentheses, let's do something else. And then we'll end our for loop, and then we won't exactly return true. What we'll do is I'll show you what we'll return instead. But C is equal to, so if we see a parentheses, what we learn to do for balancing expressions is that we need to create a stack over here. So stack of characters is equal to, so stack dot push the character on, right? And now, else if C is equal to close parentheses, then first thing we want to check is if the stack is empty, right? If we're trying to, before we pop, we want to check if the stack is empty first. If it's empty, then we have a closed parenthesis before we have an open parenthesis. So we return false. Otherwise, that's fine. We do stack dot pop. There's something to pop there, so we pop it. Okay. Now we get to the end. Now we got to check this check to make sure there were more, that there were equal number of closes, right? But what if we have too many opens? Well, instead, what we'll do is that we'll return stack dot is empty. Because if this worked, sorry, if it's a balanced expression, then we want an equal number of open parentheses and closed parentheses. In other words, the stack should be completely balanced, meaning that it should be empty by the time we get there. So we return is empty. So this will return true if the stack is empty and false if it's not empty. In other words, if there's still open parentheses over there. The other thing to do is just simply to check, is it empty, and return true if it is and false if it isn't. But I like to return the Boolean statement directly. So not too bad of a problem. So let's go ahead and look at the one that and time complexity, yeah, it's O of n, where n is the number of characters, sure. Okay, analysis. So this is one that I told you is going to be on the practice exam and on the exam itself, right? So 20 points, so you should definitely know this one. A list can be implemented in a number of ways. Compare and contrast array lists to linked lists. In what situations do you want to implement a list over another? And let me open my solutions document from the last time. I haven't created a solutions document for this exam because it was, sorry. All right, so add and remove. Basically, what I did is I like creating a table to do this stuff. And I just simply filled out add and remove. And there was reasons I didn't fill out everything else, but honestly, these were two of the hardest ones. So, I mean, you don't have to basically worry about getting it down because this video is going to be uploaded. So, you know. Okay, so, well, let's get through this. So you've got add and remove, you've got get and set, and then you've got memory usage, right? So add and remove are the complicated ones. Get and set is the easy one. So what is the time that it takes to get an item at a particular index and change an item at a particular index in an array list? It takes constant time, right? Because that's what arrays, because it uses an array. It's good at that. What about to get and set at a specific index in a linked list? O of n, because you have to iterate to that, you have to physically go through the linked list and search for that index, which is on average somewhere in the middle. I mean, those are fine over here, right? You can. It's definitely not going to hurt. I would. Let's go to add and remove. So let's start with linked list because that's actually easier than the array list. If you are adding or removing a location, so basically I wrote if you're adding or removing a location you have a reference to, such as the head or tail of a linked list, it takes constant time, right? Adding to the beginning and to the end of a linked list takes no time at all. Or if you have a pointer to that location. Let me zoom in. There we go. Okay. In all other cases, though, you got to actually search for the location that you're trying to insert to, and that will take you. That's the get that you're having to use the get node method, which takes a linear amount of time. So, but the only other thing I haven't added that I would add is that, you know, here for comparing and contrasting a linked list, the linked list would definitely be better because most of the adds do happen to be at the head or the tail, right? You remember for our merge method, that's all we were doing, adding to the head and removing from the head, and adding to the tail, right? So it was pretty easy. And same with the reverse method we did. We were just manipulating the heads and tails. So array lists in general, on the other hand, if you're adding or removing from the beginning of an array list, you got to shift stuff over to make room for it. Or if you're removing, you got to shift stuff back. Same with the middle. The end is the only exception where if you're adding to the end or removing to the end, there's nothing you need to shift over, so that takes constant time. But there's another exception to that, which is that we've got the rare case that the array list is full. So you need to reallocate, and that'll take O of n time if you have to reallocate. So the main thing is to mention that that adding to the end is constant time, except for the cases where you have to reallocate. So memory usage. So they both use up extra memory as compared to an array in different ways. So how can an array list use up your memory?
It's larger than their items in the array.
Yeah, if it's large, you have more capacity. It creates more capacity than you need. A good example we says like when we double, but we end up using now like only 51% of the space that we doubled to. So now we're just sitting with a bunch of wasted space. How do linked lists use up memory? Extra memory. Yeah.
They only use enough memory for the elements, but they also have to store the head, like the next node and previous node.
Right. Just like the array list and any array of objects, you've got to have the items you're storing are actually like memory. They're references to those items. So that's an overhead that they all have. But that's fine. That's just simply the way Java works with that. But linked lists on top of that, as you were saying, you have to keep track of the next node and the previous node. So that can either double or triple the amount of memory you're using per item. Well, the overhead, right? Because a lot of times the things you're storing, they might not just be integers. They might be, some massive objects that hold maybe a couple hundred integers each. In which case the overhead doesn't really matter too much. But if you're storing stuff by integers, now you're storing basically to store a single integer, you have to, which is 32 bits, you have to use a 32-bit reference to it, 32 bits for the previous, and 32 bits for the next. So now for every 32 bits, for every 4 bytes you're using, you're now actually using 16 bytes. So there's a bit of overhead there. Just something to be aware of. I did say refer to assignment 3 there. So, yeah, see, we're doing pretty well on the time here. Okay. So now let's go back and try taking a look at, let's see. No, that's the previous one. That's the exam practice. So let's go ahead and now look at this one. This one, again, is ridiculously easy. Honestly, I should probably replace it with a much harder problem. Which is basically, so what we need to do, but this is what we call, this is for me a kind of what, it's a lemon test or a litmus test. Basically, there's usually at least one question on the exam that basically if you get it wrong, I know there's something that's gone terribly wrong with your exam. And basically it just lets me know to yank the exam and start looking at all the answers, and they're probably going to be blank. So if you get this wrong, basically getting this one wrong is a bad indicator for the rest of the exam. It doesn't mean you automatically fail. It just means that that I can probably just write in a single-digit number and get something and that will be an accurate score. Because this is fairly straightforward if you've done Lab 2, finding the minimum and the maximum of the list. Okay, so how do we do this? Well, you iterate through each item. If it's less than the minimum, it's the new minimum. If it's greater than the maximum, it's the new maximum. That's it. So here I can just put that on the board really quickly. And a couple of you might have overthought it. Please don't overthink problems like this one. Okay. For int x in list, right? And I think it's a list of integers, right? And I refer to it as list. If x is greater than max, x is the new max. Honestly, I'll do it like this. Max is equal to x greater than max, question mark, x max min. Might as well teach you something out of this. What the heck did I just write? First off, it should work. But what in the world did I just write?
I forget what it's called. Is it kind of like a switch statement?
It's kind of like a switch statement. It's called the ternary operator. I don't know why this is still in Java. It's only still in Java because it's in C.
Yeah.
But what this is basically it's an if statement. It says that basically evaluate this expression. If this is true, do the first one. Otherwise, assign the second statement. So basically, if x is greater than max, then max should be x. If x otherwise, max should still be max. Now, it looks cool, but there's an argument for not using it, which is that it's nigh impossible to read. And again, your code should be as readable as possible. So while this looks cool, and some people use it, you probably shouldn't. Okay, it's called the ternary statement. Sorry? Yes?
I was just wondering, throwing that wrong, but, can you, say that the items of the list are small I integers, like that? 'Cause
Yeah.
Isn't the list made up of the wrapper class?
You're exactly correct. So, but remember, you can use, that's exactly correct. You can use ints and integers interchangeably, right? You can use them basically wherever you need. It'll automatically convert. So you could write integer up there and it'd be fine. Yep. So again, it's even in C#. Or in JavaScript apparently too. So you use any Boolean expression and you can chain these together. So I think it's in C#, but yeah, it's the ternary operator. There we go, ternary operator. So all these languages have it. Common Lisp. For why they do this, I don't know. They use it with merge. So everybody has something similar. But in Java, honestly, if you want to do it to one line, you can just you can simply do it like this. If you want to do something like that in one line, you can write if x is greater than max, and then do it on one line. Max is equal to x, right? Java doesn't care about white space like C doesn't. You just got to remember to put your semicolon in there. So there's no reason so there's really no reason for the ternary operator to exist, but it does exist, and some people are silly and they use it. So honestly, so please don't use it. All right, this one's actually a much more difficult problem because because it's very much like the one you had to do in Lab 2, which had a bit of a problem. Suppose you have a list of strings called list and a string prefix. Write a method that removes all the strings from lists that begins with prefix. So the first thing we want to do is write a loop that goes through all the items in the list, and then we'll work on checking the string prefix, checking to see if each word begins with that prefix. So, for example, if it was what? We could. It's a matter of just doing some. The main thing is that basically, I give you substring on the exam. So at the worst case scenario, and I'm going to start with the worst case scenario, you can use substring to do this. Okay. So for int I is equal to 0, I is less than list dot size. It's easy for me to remember what's not being recorded because I can just simply look over there now. That size I plus plus. Okay, so now we got to get string word is equal to list.get I. So now we need to check if this word begins with the prefix. Okay? So if word dot substring, right? I need to get the first certain number of characters. Word dot substring 0, right? It's going to begin with something, and then it needs to go up to how long? The prefix dot length. Because it's going to go up to, but not include the index the prefix doesn't. And we're assuming that that is bigger than the prefix. And it needs parentheses. So now that reduces that to basically the same length as the prefix. So if word, okay, and now dot equals the prefix itself. So first off, if that is that, then we do, and this is what I'd expect somebody to write. And this will be an incorrect answer right here. List dot remove, or at least an incomplete answer. Fine. Okay. So why is this an incomplete answer? Yes.
Because if you remove that, then you're basically gonna skip one, so now the list all goes down, and you're still going under
Yep. So so say we have a list of words. So human, hello, hero, and Helvetica. Okay, and let's see. So, and let's say our prefix is HE. Okay. Index 0, 1, 2, 3. Does a human start with HE? No, it does not. So we go on to the next one. Does hello start with HE? Yes, it does, so we remove it. But now when we remove it and pull it out, the indices change now. Right? So I is now at 1. I is at 1. We do I++, now we're at 2. We skip to Helvetica. So now we remove Helvetica, I++, and that gets us to 3. Is 3 greater than 2? Yes, it certainly is. Sorry, 3 less than 2? No, it's not, so we stop. And so we've left hero, and the hero escapes danger of being killed once again. So, you know. So we've got a issue. So we've got an issue here. So how do we make sure we remove this?
Put an I minus minus in the statement.
Right. So that's one. There's a lot of different solutions. One is to put an I minus minus right here. So you back up, and that way you make sure you kill the hero. Okay. The second. So basically here, what you would do is that you've got hello, 1, 2, 3. Right. Here in this case, what we'd be in your suggestion, what we're doing is that we're going. We go forward to hello. Okay, and then I go forward. Sorry, remove it. So the indices gets changed to 1 here, and then I go I minus minus. So I goes from 1 to 0, then it goes I++ and goes back to 1. So we check it again. Okay. Other solutions besides putting an I minus minus there. Yes.
Using iterators?
Using an iterator. So you just remove everything. Yeah, you could use an iterator to do this. Other suggestions? Yes.
Starting from the back of the list.
Starting from the back of the list and going forward. Starting from the back and going backwards. So in other words, if we start from the back and if we just change the for loop and go backwards instead, remove Helvetica, right? And there's nothing to shift down. Remove hero, there's nothing to shift down. Remove hello, there's nothing to shift down. And even if there was stuff to shift down, right? If there was more stuff over here, it would have been stuff we've already checked. So it would have been it's nothing we have to recheck as a result. So there's even more ways to do this one. Yes.
Make a new list and just add everything onto that.
Yeah, but that's boring. My personal favorite change is change this if into a while. And now now the indice the I doesn't change, even though the stuff that we're changing does. So here, basically, we remove hello. Here would be at index 1 now, and then we check again to make sure. Then we check again for Helvetica, right? And then we'd go on to the next one. So, and it's still, even though it's a nested loop, it still takes O of n time. Okay, so now the other question is, this is great, but this looks messy. If only there were some method we could use that would check if a string started with some sort of prefix. you know, like if there was a starts with method. I think that's what it's called, at least. Starts with. There we go. So that should be a correct solution, which is a lot cleaner. This was actually the first time I gave this exam at Temple. This question was a 10-point question on the first on their first exam, and I didn't realize and they hadn't gone through a problem where they've had to remove stuff before. So that was the first time they had to think about. So a lot of people got like a couple points off because they didn't even realize the indices would get removed or get messed with. And I had completely forgotten that was a factor. So, I was just trying to come up with an interesting problem. But anyway, string starts with string platform. Yep, looks like it. It even takes in a string called prefix. So yeah, looks perfect for us. There's also an ends with, So there we go. So that's basically, that should be all the questions on the exam, on the practice exam. So, so how else so you might be going and panicking going, okay, but I feel like I need more practice. Okay, so let me show you the magic of what to do then. Data, structures, exam, linked lists. Most data structures classes cover linked lists. In fact, most data structure classes cover almost all the same stuff we do. Right? And some of the stuff is like stuff we won't know. Like they'll go into more detail about big O notation. We put that in different classes. Assume linked list is a doubly linked list. Write the commands to delete a head node. Insert a node immediately after M. Swap M and node head. Don't swap the data, actually swap the nodes. And then complete the following method, the contains method. They've even got a recursion question. Find the last, which finds the last node of the linked list. So there's stuff like that. Right, some of the stuff will be in C, but like you can still translate that out to figure out what you need to do. Right? So for nodes, we'll be using node pointers and stuff. I will admit to searching through other people's exams to find interesting questions to ask. So there is a lot of there's a lot of practice out there. Unlike intro classes, which are all very, very different, and they cover different things in different orders. Data structures, yeah, that covers different things in different orders, but a lot of the same material. But almost every data structure class covers linked lists. It covers trees. It assumes about recursion, or it teaches you recursion, and then it might teach you hash tables, and it will probably go over graphs as well, which is a lot of the stuff we're going over. So there's a lot of resources, or linked list interview questions, because there's a bunch of them. These are, so let's see. Print the middle of a given linked list. Flattening a linked list. Don't know what that means. Delete the middle of a linked list. So flattening a linked list, where every node represents a linked list. Ooh, that looks nasty. So basically each thing is like a 2D linked list there. So then turn it into a single linked list. So that looks actually fairly interesting. So there's a lot of good. So there's a lot of good practice there. Rotate a linked list. So this is kind of like reverse, but the idea here is that 10, 20, 30, 40, 50, 60, and the K is 4. Then it's 50, 60, 10, 20, 30, 40. Right? And then they'll give you answers to do that stuff. But you should try it all yourself first. But these are, and when they're when there's these kind of problems, like interview questions, they would allot like 30 minutes to 45 minutes for you to solve, and there'd be somebody there for you to point you in the right direction. So these are questions that would be harder than you'd think. Sorry, that would not be harder than you think, but would be less hard because you have at least somebody to keep you from going off the rails. So don't worry if you can't solve them. But this one's actually a good one. Detecting a loop in a linked list, which basically figures out if the link has if basically it's loops it around itself accidentally. One of the pointers loops back to the linked list somewhere. So a lot of good interview questions, and that's a lot of good places to look. So I'm pretty much done with today's lecture. Now, with regards to homework, I generally do try to give out homework, but I haven't created one. So worst case scenario, I might give you a homework, and it'll be, let's see. Well, it would be due? Well, unfortunately, the annoying thing is I have to take into account spring break, right? So when does spring break start? Like next Friday, right?
Yeah.
So it would start when? Like March 2nd? We have class the 2nd. Right. Right, that's the last day of classes. So yeah, so just for reference, I expect you to work exactly as much as I do during spring break, which is precisely 0. So I will when it comes to like homework being due, I won't expect you there won't be anything if I assign something before spring break on like that Friday the 2nd, it will be due like on the 6th, it will be due like on that 16th on the next lab when we finally get back, So like on the 16th or the 17th. So you have a while to work on it. So so I'm going to figure out what I need to do for you guys, but I don't want to necessarily cut into spring break. So we'll see we'll see what happens. You might luck out and I decide that it's too much of a bother and I'll give you an assignment and you might get a bye on this case. All right.
Detect if your linked list goes back on itself problem.